Hey everyone, and welcome. Today, we're going to decode the universal language of data, SQL. If data is the world's most valuable resource, then SQL is pretty much the language we have to speak to unlock it. It's how we ask questions and get answers from these massive databases. So let's dive right in and see how it all works.
But how do you actually talk to a database? You can't just ask it a question in plain English, right? You need a very specific, super-structured language that both you and the computer can understand perfectly, without any confusion. And that's the fundamental problem that SQL was built to solve.
And the answer is structured query language. Now, let's get one thing out of the way right now. You might hear some people call it SQL, but the official preferred pronunciation is just to say the letters, SQL. It's the global standard for managing and pulling information from what we call relational databases. And trust me, those are the backbone of countless apps you use every single day.
Okay, so to really get a handle on this language, we're going to look at its anatomy. First, we'll talk about why we use it. It has 5 core intentions. Then, we'll dig into its vocabulary, its grammar, and finally, who even makes the rules, before we wrap it all up with the big takeaway.
First up, purpose. See, SQL isn't just one single thing. It's more like a toolkit with different tools for different jobs. You can think of them as different moods or intentions you have when you're talking to the database.
And yep, there are exactly 5 of these core intentions. We officially call them sublanguages. Each one is basically a family of commands, all grouped together by what they're trying to do, whether that's building the database from scratch or just asking it a simple question.
So here they are. It all starts with defining the database structure. Once that's built, we can query it for information or even manipulate the data inside. And then, holding it all together, are tools for handling transactions and controlling who gets access. Let's take a quick look at each one. First up, we've got the Data Definition Language, or DDL. Think of this as the architect's tool. You use commands like create table to build the entire skeleton of your database. The tables, the columns, all the rules. It's literally the blueprint. Next is the one you're probably going to use the most, the Data Query Language, or DQL. This is all about asking questions and getting information back. Anytime you see a command that starts with select, that's DQL. It's how you read the data without ever changing it. So, what if you actually want to change the data? Well, that's where the Data Manipulation Language, or DML, comes into play. These are your action commands for adding new info with insert, changing existing stuff with update, or getting rid of it entirely with delete. And finally, we've got a pair of sublanguages for safety and security. The transaction language, DTL, is kind of like an all-or-nothing switch for big operations, like a bank transfer. The whole thing has to work or none of it does. And the control language, DCL, well, that's the security guard, managing who has permission to see or change.
Okay, so we know the intentions behind SQL. Now let's zoom in a bit and look at the actual words. Every single SQL sentence, it doesn't matter how simple or complex it is built from just a handful of core building blocks. So let's use this simple SQL statement as our example. All it's doing is asking for the names of cities that have a population over 15,000. Now let's tear this thing apart and see what it's made of.
This one sentence is built from 5 core parts. First, you have keywords, like select and from. These are the verbs, the action words. Then you have identifiers, like city and name. Those are the nouns, the names of our tables and columns. Literals are just the specific values, like the number 15,000. A whole phrase like population greater than 15,000 is called an expression, which the database checks to see if it's true or false. And finally, you can add comments for other people to read, which the computer just ignores. Every single query is just a mix of these 5 things. So we've got the vocabulary, but how do we put it all together correctly? Well, that brings us to grammar. SQL is a structured language for a reason. It has very strict rules about how you combine these building blocks to form a complete instruction.
The grammar really comes down to 2 key ideas. A statement is the entire command you give the database. Think of it as a full sentence. And that sentence is made up of different clauses, which are like smaller phrases that each kick off with a keyword, like select name or from city.
And this is a perfect example of what those rules look like. I know, this looks pretty intense, but it's just the official grammatical blueprint for an insert command. The words in all caps are the keywords, the square brackets show you parts that are optional, and the little dots just mean you can repeat something. And here is that blueprint in action.
This command follows the rules we just saw perfectly. It's inserting 2 new rows of data right into our city table. See, this is how that abstract grammar becomes a real, concrete command that does something.
But that begs the question, who actually writes this rulebook? It's not like every database company just makes up its own version of SQL. Nope. There's an official international standard that governs the entire language.
The first standard came out way back in 1986. Today, it's governed by both the American National Standards Institute, that's ANSI, and the International Organization for Standardization, or ISO. This is what ensures that the core of SQL works pretty much the same whether you're using a small open-source database or a giant enterprise system.
So let's bring all this home. What we've really done here is dissect the anatomy of a language, from its big picture purpose all the way down to its punctuation.
So here it is, the big takeaway. Speaking SQL fluently really comes down to these 4 pillars. It starts with the 5 sublanguages that define your intent. You use the 5 language elements as your vocabulary. You combine them using a formal syntax that acts as the grammar. And it's all held together by an international standard that makes sure everyone is on the same page. If you can master these, you can speak to almost any database in the world.
Knowing this structure, this anatomy, gives you the power to ask incredibly powerful questions with confidence. So that just leaves one final thought for you. Now that you know the grammar, what will you ask the world's data?